Data synchronization is the process of establishing consistency among data from a source to a target data storage and vice versa, and the continuous harmonization of the data over time. It is fundamental to a wide variety of applications, including file synchronization and mobile device synchronization, for example, for PDAs. File-based solutions. There are tools available for file synchronization, version control, distributed file systems, and mirroring, in that all these attempt to keep sets of files synchronized. However, only version control and file synchronization tools can deal with modifications to more than one copy of the files. File synchronization is commonly used for home backups on external hard drives or updating for transport on USB flash drives. The automatic process prevents copying already identical files, thus can save considerable time relative to a manual copy, also being faster and less error-prone. Version control tools are intended to deal with situations where more than one user attempts to simultaneously modify the same file, while file synchronizers are optimized for situations where only one copy of the file will be edited at a time. For this reason, although version control tools can be used for file synchronization, dedicated programs require less overhead. Distributed file systems may also be seen as ensuring multiple versions of a file are synchronized. This normally requires that the devices storing the files are always connected, but some distributed file systems like Coda allow disconnected operation followed by reconciliation. The merging facilities of a distributed file system are typically more limited than those of a version control system because most file systems do not keep a version graph. Mirror. A mirror is an exact copy of a data set. On the Internet, a mirror site is an exact copy of another Internet site. Mirror sites are most commonly used to provide multiple sources of the same information, and are of particular value as a way of providing reliable access to large downloads. Synchronization can also be useful in encryption for synchronizing public key servers. Theoretical models. Several theoretical models of data synchronization exist in the research literature, and the problem is also related to the problem of Slepiana-Wolf coding in information theory. The models are classified based on how they consider the data to be synchronized. Unordered data. The problem of synchronizing unordered data is modeled as an attempt to compute the symmetric difference between two remote sets and of b-bit numbers. Some solutions to this problem are typified by wholesale transfer. In this case, all data is transferred to one host for a local comparison. Timestamp synchronization. In this case, all changes to the data are marked with timestamps. Synchronization proceeds by transferring all data with a timestamp later than the previous synchronization. Mathematical synchronization. In this case, data are treated as mathematical objects and synchronization corresponds to a mathematical process. Ordered data. In this case, two remote strings and need to be reconciled. Typically, it is assumed that these strings differ by up to a fixed number of edits. Then data synchronization is the process of reducing edit distance between and up to the ideal distance of 0. This is applied in all file system-based synchronizations. Many practical applications of this are discussed or referenced above. It is sometimes possible to transform the problem to one of unordered data through a process known as shingling. See also, SyncML, a standard mainly for calendar, contact and email synchronization, synchronization. Notes.